Okay, guys, so we'll start this lesson with a little bit of a warm up, kind of get you guys going. So, with this first integral, it has three terms. Just like derivatives, you can integrate them separately. So, the first term, 3x squared, is the power rule. Add 1 to the exponent, so you're going to have x cubed, and then divide by your new exponent. So, we'd be dividing by 3, and the 3's would cancel. Um, as always, you can always figure out whose derivative would get you this, and that technique works in a ton of cases. That the power rule is probably the best bet here. But with trig, I would do this. Whose derivative would get you positive sine x? And we know the derivative of cosine is negative sine, so the derivative of negative cosine x would get you positive sine x, because the negatives would cancel. Same deal here. You could do that. Or you can think about it as 7 is really 7 times x to the 0, because x to the 0 is 1. So add 1 to the exponent, so x to the first now, and divide by your new exponent, and that'd be still 7. So there's that, and you will always have a plus c, and I'll say that until further notice. This is called an indefinite integral. You always have a plus c. So there's kind of your basic rules that we've been doing, just doing a power rule. Moving on to the second one here, you're going to want to, you can see right away that you see a quotient, right? And there's no quotient rule for integration, but if you ever see a quotient, you can try to rewrite this, or, any kind of other algebra. That's always a good go-to, but we're going to jump to, go ahead and do a u sub here. So we pick a u whose derivative might be in the problem, and if you do have a fractions, kind of one of your backup moves is just to pick the denominator, and I know its derivative, so du, would be 2x, and I'm going to put my dx over here. Well, we have an x dx, so I'm going to divide that 2 over, and you'd have x dx. So rewrite your integral. The x dx comes out, and the 1/2 du goes in. I usually put my coefficients out front. And then all you have is the x squared plus 4, which is u, so you have 1 over u. Now, what some people might do would be like, oh, well, I'm just going to rewrite this as u to the negative 1. Okay, now this is where I would caution you to be careful. If you do the power rule here, if you add 1 to it, well, now you get u to the 0, which is kind of strange, but divided by 0, which is definitely strange because you can't divide by 0. So this is actually not the way to do this. And that leads to what we'll be doing today. The integration of 1 over u du should sound familiar. And that's why I always had you guys write the du off to the side. Because integration 1 over u du is ln of u. Two special things. You need to always remember absolute values. It's the ln of the absolute value of u. That's because you can't take the ln of a negative number. So that's why that has to have absolute values around it. And then still has a plus c. So, to finish off this problem up here, I'm going to do that in green. It would be, you still have the 1/2. The 1 over u du becomes ln of the absolute value of u. So I'll plug my u in, it's x squared plus 4. And then you don't forget your plus c. And that problem would be done. So a slightly different looking example here is this one with sine and cosine in it. And right off the bat, you see a product and maybe a quotient. So we could be thinking u sub. Now it's interesting, this one, picking a u. Now you could pick cosine as your u because its derivative is sine, a negative sine, and that's in the problem. But you could also pick sine as your u, and its derivative cosine's in the problem. But let me show you what not to do first. If you picked this, again, its derivative would be negative sine x. But now your sine x, part of it is in the denominator. Dx, I guess that would be this. That would be kind of like in the numerator, because you can always write that over 1. So a standing rule is your du should never go in the denominator. You should never have something that looks like this. That will be bad. So that's what not to do. So let's pick, instead of cosine as your u, let's pick sine. And so the derivative of sine is cosine. And I'll put my dx there. And you can see now that cosine x dx will just be swapped out for du, which is great. And then you just have 1 over u for 1 over sine. And now that's our rule. The integration of 1 over u du is the ln of the absolute value of u. So let's plug sine x back in for that, and don't forget your plus c. And you're done. All right, so on the other side of that, if you're going to be doing ln, you should probably talk about e as well. So this is, I like to say this is my favorite one. If you ever get an equation in the form of e to the u du, its integral is e to the u plus c. So in our problem here, we have e to the 3x plus 1. Well, we need it to be e to the u, so we're going to call u 3x plus 1. And this you have to do. I know it seems like a silly step, but you have to do this. You have to have e to the u. So the derivative of u is du. The derivative of this side is 3 dx. Now, you just have dx. You don't have an extra 3, so we're going to divide that 3 over. And now you're ready to go. So swap everything out. So now this would be e to the u, because 3x plus 1 is u. dx is the same thing as 1/3 du, so I'm going to put a 1/3 out front, and du here. And what's nice about this is now you have the integration of 1 over u du, which is e to the u. So e to the 3x plus 1. Don't forget your 1/3 from above, and always plus c. All right, so let's see some different examples. So in our next one here, we have an ln of x to the 5th power all over x. One of the most challenging things that you're going to come across is what do you pick for your u? And that's always that's the issue. You can see this problem has a quotient rule and a chain rule. So it's pretty obvious that we're going to have to use a u substitution. But what do you pick as your u? And that's hard. So I always tell people this: pick a u whose derivative is in the problem. And if you know your derivative rules, it makes life a little easier here, because the derivative of ln of x is 1 over x dx. Okay, so why is that nice? And I'll try to do this color-coded here. The ln of x is just u, okay? So you have u to the 5th on top. And technically, you have a 1 over x dx. So all of that can come out, and you just put in du for that. So now your problem is this. So now you actually integrate. So now we use our power rule. So add 1 to the exponent, divide by your new exponent, plus c, right? And all there is to do is just put your, I'll change color here, put your u back in. So now you got ln of x to the 6th over 6 plus c. And there's your answer. All right. Sorry. Now the interesting thing about this integration of tangent x. First off, you'd think you just know it. But whose derivative is tangent x? And some of you guys might say secant squared. But that is the derivative of tangent x. We want to know whose derivative is tangent x. So, well, you might say, oh, yeah, that's secant tangent. But the derivative of that is a product rule. So that'd be a mess. So it's actually neither of those. And you don't know the answer to this. You don't know whose derivative is tangent x. So this takes some creativity. So when you're stuck, I suggest rewriting. And tangent is sine x over cosine x. Now you have a quotient rule. So that kind of opens the doors to, oh wait, then it might be a u sub since I have a quotient rule. Again, you don't want your du to be in the denominator. So if you picked your u to be sine x, then your derivative would be cosine x, but you don't want du in the denominator. So let's switch those two. Let's say their u is cosine x, and as I said earlier, a backup kind of general rule is pick the denominator for your u. It'll help you out because its derivative is negative sine x dx. What's cool is you got sine x dx. You just don't want the negative. So we're going to move the negative over and substitute out. So the sine x dx is coming out and a negative du is going in. And all you have left then is a u in the denominator, nothing on top, so that's a 1. And hey, what do you know? We have 1 over u du. So that's integration of 1 over u du is the ln of the absolute value of u. Don't forget that negative needs to come down. You still have a plus c. And in the middle here is u, which is cosine x. So our answer is this. All right. So there's some of the really good ones for you. Good examples of, say, rewriting a little bit, some strategies on what u to pick. Like I said, sometimes picking your u is the hardest thing. So maybe we'll do just a couple more here just to help you out. So this one, again, looks kind of all over the place. Definitely some quotients. There's an e in here. So you're probably going to want to either try to rewrite this or maybe do a u sub. In my opinion, the easiest way to see this is rewriting it first. So let's just straight up rewrite that. E to the, I'm going to make that x to the negative 2. So technically I just brought that up because I didn't want a fraction in the exponent. And then same thing here. This I'm going to actually bring up. So times x to the negative 3. I don't know why, in my eyes, I just see this a little bit easier this way. So now this is a product rule. So let's pick a u. And I want to pick a u whose derivative is in the problem. And don't forget, when you take a derivative, you subtract 1 from the exponent. So if you think about that, when you take the derivative of this, you do get negative 2x to the negative 3 dx. And we have this part. Actually, I didn't write the dx still, but the dx is still there. So we already have that right here. We don't want the negative 2 now, so let's move that over, x to the negative 3 dx, and do our substitution. We called this u up here, and this is your du. Don't forget there's a negative 2 as well. So I like to tell people this is my favorite one because the integration of e to the u du is e to the u plus c. Bring down your coefficient, and last but not least, plug in whatever u was. So negative 2 e to the x to the negative 2 plus c. Or if you want to write it nicely, that would be negative 2. Oops, sorry, I wrote that kind of weird. That'd be negative 2 e to the 1 over x squared plus c. Either way, there's your answer. Okay, and one little one here. Looks like you got a couple things going on, a product and a chain. So you have to probably go with a u, pick one whose derivative is in the problem, and you take the derivative of 6x, you get 6. That's not going to help much because you still have an x squared. And here, I want to actually do this wrong for you. If you did this, you'd get 6 dx. You'd divide over your 6 because we don't have an extra 6 in the problem. So what you would have is 1/6 du going in. This would be u, right? And then this would still be here. So you'd have the cosine of x squared still in there. And a huge problem is that you have x's and u's at the same time in a problem. That'll practically never happen. So that's how I know you're going to do something wrong. So I'm showing you something wrong so that you know when to stop. Sometimes one of the hardest things is if you don't know if you're doing it right or wrong. Well, that's a big clue. If you have x's and u's in the equation still at the same time, that's wrong. And if you look at any problem we've already done today, when we are going to integrate it, all of the variables are u. So it's called u sub. So instead of picking 6x, x squared is a better pick because its derivative is this. And although we don't have a 2, we do have an x dx. So I wanted to show you this problem because we can divide this 2 over and still have an x dx, right? And if you think about this, and this is my hint to you, 6, this is all multiplication in here, right? 6 then is a coefficient. So you can actually bring that guy out front. So I'm going to rewrite the original problem for you. Oops. I just took the 6 out front. Now, why is that helpful? Because x dx is really 1/2 du, equal to that. So I'm going to have a 1/2 and a 6 out front and a du in, and that x dx comes out. And I'm going to have cosine of u now. So now look, our whole problem has u's. So you can integrate this. Remember how we integrate trig is whose derivative is cosine, and that answer would be sine of your u, so x squared. Out front, you have 1/2 times 6, so that's 3. And don't forget plus c. All right, guys, I hope it helped. Don't forget, use Remind if you have questions. I will be available for that. Pause the video, rewind the video, watch as many times as you need to.